Now we're going to talk a little bit about how you use molar mass in your conversions. So again, we have to remember that 1 mole is going to be equal to our atomic mass. And then that conversion factor we're going to be able to use to do some more dimensional analysis. Excuse me. So here it's telling us that we have 1.25 moles of water. And that's what we're going to start with. Always when you write this down, put your label and put the substance, because eventually we're going to be changing from one substance to another, and you need to keep track of what you're doing. So here again we know that 1 mole of water is going to be equal to its atomic mass. So hydrogen weighs 1.0 grams, and there's 2 of those. And we know that oxygen weighs 16.0 grams, and there's 1 of those. So we know for every 1 mole of water, there is 18.0 grams of water. Okay, so now I'm going to slide down where this is written a little neater, and you can see how this problem is set up. Here 3 significant figures, so you need 3 in your answer. So this is going to be rounded to 22.5 grams of water for your final answer. Okay, so that's how you convert from moles to grams. Now if we want to go from grams to molecules, we're going to use what we just learned plus the previous video when we talked about converting from molecules to moles. So here it's telling us we're going to start with 25.5 grams of sodium chloride. The only way we can convert from grams to molecules is if we convert to moles first. So if anything is in grams, you always have to convert to moles first. So we need to look up our atomic mass for sodium. Sodium is 23.0. We look up chlorine. Chlorine is 35.46, so we round that to 35.5. So again, remembering that 1 mole is equal to these 2 added up, so this is 58.5 grams is equal to 1 mole. Okay, so here we know our 58.5 has to go on the bottom because we want our grams of sodium chloride to cancel out, and our 1 mole will go on top, and that will give us our answer in moles. Okay, so we'll do that division and get our answer in moles. So as we scroll down here, okay, you can see that that's our first part of our problem. If we go back up, it asks us though to go to molecules. So after we're in moles, okay, you can get your answer, or we can just continue on. And sometimes it's easier just to set up the whole problem. So if we do our grams first, again, we have 58.5 grams of salt for every 1 mole of salt. Once we're in moles, we now know from the very first video that 1 mole is equal to Avogadro's number. Okay, so we now can cancel this out by putting our 1 mole down here and Avogadro's number up here. So this is what I would call a 2-step problem. So you can cancel out your grams by using your atomic mass, and then you can cancel out your moles by using your conversion factor of 1 mole is equal to Avogadro's number. Then you would take 25.5 times Avogadro's number and divide by your 58.5. Okay, as you punch that into your calculator. So again, that written a little neater so you can see that better would be here. When you're done punching in your calculator, you go back and look. This is 3 significant figures, so we need 3 significant figures in our answer. And so that's how you would do a 2-step problem going from grams to molecules. Okay, here's another one. Starting from grams, just going to moles. So that should be just a 1-step problem. 25.5 grams of NaCl. We add up the mass again. It was 58.5 looking at our periodic table, and we know again that 1 mole is always equal to our atomic mass. So that's our conversion factor, and so our 1 mole has to go with this. We do our division, find our answer. Here we started with 3 significant figures, so we should have 3 significant figures here. So I'm not sure what that is when you put it in the calculator, but we'll make it maybe 0.442 so that we have the correct number of significant figures. Okay. Another one here, how many grams are in this many molecules? So again, just like our first problem we did here, if we're in molecules, we know that Avogadro's number is equal to 1 mole. So we would use Avogadro's number and 1 mole. That's our conversion factor. Okay, those numbers can never change. Then it asks us here to get to grams. So then we have, this would be 1 mole of strontium chloride. We know that 1 mole of strontium chloride is always equal to the atomic mass. So we would have to go to our periodic table. Okay, we're going to look up our masses here. Strontium weighs 87.62, so 87.6. Chlorine is 35.5. So when we add that together, we're going to get 159 grams. So we know 159 grams, again, our atomic mass, is equal to 1 mole. So our second conversion factor. Okay, our moles will cancel out, and we will end up with grams for our final answer. So again, written a little neater here. Molecules cancel out, moles cancel out, we end up with grams. We started 3 significant figures, we end with 3 significant figures, and that is our final answer. So now you've done a couple 2-step problems.